Okay, normal force. Normal force only exists if you have a surface in contact. Like you see here, maybe I should draw something. Okay, I see here we have a surface in contact with the block. Then we have a we have a surface. Okay, important thing, we must have a surface in contact the block. Then it must have a normal force. Okay, like this one also there is a surface. You see that in contact. Here also there is a surface in contact. You see that surface in contact, and this one also a surface in contact. So all these contribute to the normal force, and normal force must be perpendicular to the surface, no matter how the surface is. Okay, horizontal, inclined, wall, ceiling. Okay, the normal force is always 90 degree to the surface. You can see that 90 degree, 90 degree, 90 degree, 90 degree. So like for example, this inclined surface, never go to draw, oh, normal force must going up. Yeah, this is wrong. This is wrong. Okay, so normal force must always perpendicular to the surface, 90 degree, 90 degree to the surface. Okay, so remember, whenever you have a surface, you must have a normal force, and normal force must be perpendicular to the surface. Okay, so all right, so be careful with this. Yeah. Okay, next is about friction. Friction also, you must have a surface in contact. Okay, you must have a surface in contact, and it must, provided the surface must have is a rough surface. The keyword is must be a rough surface, or sometimes it can give you the value of mu s or mu k, the coefficient of friction. It give you this value mu, give you the mu value of the surface, or he mentioned the surface is rough. Okay, so we can say the surface has a friction. Okay, the thing difference between friction and normal force is friction, the direction of the friction must be parallel to the surface. Unlike the normal force is perpendicular to the surface, the friction must be parallel to the surface and opposed to any motion. Yeah, opposite any velocity, opposite any direction of motion. Opposite the direction of motion. Okay, we have two types of friction. Okay, first is the static friction, and then we also have the kinetic friction. Can you see the diagram here? All the frictional force is always parallel to the surface. Friction must be always parallel to the surface. Like the normal force, it is perpendicular to the surface, but friction must be parallel to the surface. So whenever you have a surface in contact like this, you see, like a surface in contact, so probably it will have two kinds of forces. One is the normal force, and another one is the normal force, another one is the frictional force. Okay, so pay attention to this. Okay, so first of all, I want to talk about the difference between static friction and kinetic friction. Okay, so what's the difference between static friction and kinetic friction? Okay, so what actually the difference between static friction and kinetic friction? What I can say overall is static friction is for okay, static friction is for non-sliding object. I don't use the word moving. Yeah, I don't use the word moving. I better use the word sliding, non-sliding. Kinetic friction is for those object already sliding. It is for this one is non-sliding object, and this one is for sliding object. Already sliding. I mean the two surface in contact already sliding. Okay. So when an object is not sliding yet, it experiences static friction. When an object starts to slide, slide through the surface, we say it experiences kinetic friction. Why I don't use the word moving? Why I don't use non-moving object? This one is moving object. Yeah. Why you use the word sliding? Because got another example like wheel, rolling wheel. I want to talk about this. This is a rolling, yeah, a rolling wheel. Rolling wheel, yeah, through that roll through the road, yeah, it roll through the road. Okay, so what I want to ask you, this rolling wheel, is it experiencing static friction or kinetic friction? What kind of friction it experience? This rolling wheel, what I can say is, if it is still rolling, we say it experience static friction. This rolling wheel is moving. It's moving. Why we don't say it experience kinetic friction? Because kinetic friction is for the moving object. Yeah, this rolling wheel is exactly moving. Yeah, but why it experience static friction? Yeah, we can say this rolling wheel it experience static friction, not the kinetic friction. Yeah, it experience static friction. Why experience static friction instead of kinetic friction? Okay, it is because this rolling wheel is actually not sliding across the road. Yeah, this is the road. Okay, actually it is not sliding across the road. Yeah, you see the surface in contact, like for the at the 0 second. Okay, at 0 second, this point A is in contact with the road, isn't it? After some time, after it roll down the road, yeah, after it roll down the road, I can say, can I roll this object? Yeah, can I roll this object? Yeah, can or cannot? Yeah. Let me see. Yeah, let me see. Let me try it out. Yes, I can roll it. I just rotate it. No. Again, it should rotate to the right. You see? So at maybe at 1 second, yeah, this is the road. This is the road. Okay. So at maybe at 2 seconds, the point B last time is over here. Yeah, this is the point B. Now point B is over here already. Okay. Point B is over here. Yeah, this one point B. Yeah, just put a point B. Okay, point B now is over here. You see, so you see, this is still rolling down the road. Yeah, the wheel. Okay, so you can see all the points just touching the road. It never sliding across the road. It never sliding. What about sliding wheel? Maybe I want to talk about a sliding wheel. Yeah, maybe I just take a sliding wheel. Okay, yeah. Which is let me show you. Okay, maybe another example. This is a sliding wheel. Sliding wheel. Sliding wheel. What is actually sliding wheel? Sliding wheel means yeah, just now it's rolling like that. Now it's sliding. Sliding means like that. You see that? Sliding. Yeah, this wheel is actually already jammed, cannot roll anymore. Yeah, it cannot roll, it cannot roll, but it slide across the road. It slide across the road at 0 second. The same point still in contact with the road. The point A still in contact with the road after 2 seconds. Still the same point in contact with the road, which is the point A. This is called sliding wheel. This sliding wheel, it experiences kinetic friction. So this is the example that experience kinetic friction. You see? The sliding wheel. This is the sliding wheel. The rolling wheel is still experiencing static friction, but the sliding wheel is experiencing kinetic friction because it is the same point touching the road all the time. The same point sliding across the road, but this one is different point. Yeah, all the different point. Yeah, not too clear. Yeah, all the different point on the surface area in contact with the road when the wheel is rolling. So we can see the rolling wheel is still have grip. still have grip on the road. It still have the, you know, it still have the grip. It still have the grip on the road. Yeah, I still have the grip on the road. So this wheel is actually experiencing static friction, not the kinetic friction. This sliding wheel means it lose the grip already. We can say it lose the grip on the road. This sliding wheel is lose the grip on the road. You can imagine, like, if you're driving a car, like this one is for you're driving a car, driving a car safely, safely during a sunny day. Driving a car safely during a sunny day. So rolling wheel, the wheel still have a grip on the road. It experience static friction. But compared to this kinetic friction, you are actually like the car skidding. You know, lose grip on the road already, skidding during a rainy day. This one is experiencing kinetic friction because the wheel cannot turn, yeah, and the same point sliding across the road, the same point, you see, the same point. So we can say effectively this wheel already lose the grip on the road, yeah, lose the grip already. So this is experience kinetic friction. Okay, so this is one example, okay, about non-sliding and sliding object. So don't say that, oh, non-sliding means the object is not moving. No, it's just non-sliding. Or we can say no. In other words, we can say better like that. No relative. Maybe put it like this way. Maybe I write it down first. I wrote it down already. So static friction is if there is no relative motion between surface in contact. That means between the two surface not sliding. No relative motion between the surface in contact. Then it is static friction. But if kinetic friction is you have relative motion between the surface in contact, the surface in contact already slide through each other. Relative motion between them, and you experience kinetic friction. Okay. Or all right. Now another thing is static friction. It has various value. But kinetic friction has a constant value. The value is constant. Okay, static friction has many values up to a maximum value, which is mu Sn. Okay, static friction has a various value up to a maximum value, which is mu Sn. Mu Sn is actually the maximum value. So static friction can be lower. Yeah, it can be lower than mu Sn. But kinetic friction cannot. It's a constant value, constant at mu Kn. Okay. I will explain later about various value and constant value between static friction and kinetic friction. First of all, we need to look at what is actually mean by mu s and fs. What's the difference between fs and mu s? Okay. So mu s and mu k, they are called coefficient of friction. Coefficient has it has no unit. Okay, coefficient. But friction is a force. It has unit. Unit is Newton. Okay, unit is Newton. Yeah. Friction is a force. Okay. So why friction is a unit Newton? Because yeah, we can say normal. This one is the normal force. Normal force is Newton. So friction is also Newton. Okay. Whereas the coefficient has no unit. Okay. Understand? You understand that? Okay. Okay. Now. Okay. So now why friction? Why the formula friction equal to mu Sn? So what actually is the meaning of coefficient and what is the meaning of friction? Okay, look at the formula of mu Sn again. Okay, or maybe general formula. Look at the general formula. Static friction is mu Sn. Kinetic friction is mu Kn. So both of them have almost the same formula, mu n, isn't it? The friction is mu n. So one is actually mu n. Why the formula mu n? Why friction formula is mu n? So okay, we know that this coefficient, this mu is called the coefficient, and this n is the normal force. Normal force, isn't it? This is the coefficient. Okay, coefficient. Okay, this coefficient is based on the surface in contact. It's based on the surface in contact. This mu value is based on the surface in contact. So if it is let's say less rough surface, then it have a smaller mu. Okay, but if it is a very rough surface, okay, maybe I should again. Okay, so if it is a less rough surface, you have a very small mu. But if it is a very rough surface, then you can have a very high mu. So maybe normally this mu value must be less than 1. Yeah, this mu value overall, this mu value must be less than 1. So must be between 0 to 1. This mu value must be between 0 to 1. So if less rough surface, the mu normally is maybe I give an example. Maybe it's only 0.2. Yeah, maybe 0.2. But very rough surface, the mu can be 0.4. Understand? So the very rough surface has a very high mu. Less rough surface has a small mu. So the rougher the surface, what we can say is the rougher surface with a higher mu, with a higher mu, the surface will contribute to more friction. More rougher surface will have higher value of mu. Will bring about higher friction to the object or to the moving object. Okay, so rougher surface, higher mu, more friction. Okay, and then friction also depends on normal force. Why friction also depends on normal force? Basically, if we look to one simple example, like a crate. Okay, we compare to two different objects. Yeah, one small object and one big object. Okay, this object, okay, maybe we can say this object is only 1 kilogram. But this object is 1,000 kilogram. 1,000 kilogram. So and this floor is a rough surface. So when rough surface with a certain value of mu, yeah, maybe 0.2 the mu. Okay, it's a rough surface, 0.2. So we know that it has a friction, isn't it? It will bring friction to the object, yeah, to 1 kilogram and 1,000 kilogram. But which crate is harder to push? Let's say there's a person here who want to push this crate 1 kilogram and 1,000 kilogram. Which one seems to be harder to push across the rough floor? Which one will experience higher friction? Of course, the one with 1,000 kilogram. Why? Because the 1,000 kilogram will have higher normal force. Compared to the normal force, N1 and N2. The N1 should be smaller normal force. The N2 will be higher normal force. All of this because we know that. Okay, let us draw the free body diagram. Okay, this one has a weight. Okay, this one is the weight 1, and this one is the normal force 1, isn't it? And then this one is the weight 2 and normal force 2. So we know that for this case, we know that N1 is equal to W1, this N2 equal to W2. So because we know that the weight 1 is has smaller weight, so the normal force will become smaller. But this one has a bigger weight, and W2 is a bigger weight, so it experiences a higher normal force. What is normal force? Normal force is actually the forces exerted by the surface in contact. Because this is the contact surface. You understand? This contact surface gives the normal force to the object, to support the object. So the heavier the crate, the higher the normal force, isn't it? The heavier the crate, the higher the normal force. So if you have more force in contact, more normal force, we have experienced higher friction. Will turn out to have a higher friction. Yeah, friction in the opposite direction of motion. Yeah, let's say we want to move the crate to the right, so the friction will be to the left. Okay, so of course this friction 2 will be higher than friction 1. Okay, this one friction will be lower. You understand? So if the lower the normal force, yeah, smaller crate, lighter crate will have less normal force, so the friction also will be lesser, so easier to push. This one easier to push. But if a heavier crate like this, with a large weight, high normal force, then it will be harder to move this object because it experiences higher friction. Okay, so friction also depends on normal force. So the heavier the object, the higher the normal force, the higher the friction also. Okay, so so friction depends on two factors: the condition of the surface, rough, less rough, or very rough, and also depends on the mass of the object. The higher mass, higher normal force, higher friction. Okay, now good. All right, now okay, now I want to go deep into why static friction has various value but kinetic friction has a constant value. Okay, what is actually the essence of static friction? Okay, now look at this. Static friction has various value less than or equal to mu Sn. Kinetic friction has a constant value mu Kn. So let me tell you one story, yeah, or one example. Okay, based on this graph. Okay, like here you can see actually this part is a static friction because it's a static region. The object is not moving. This is the friction. It have a low value and high value. Kinetic friction is a constant value. So let me okay. Mu Sn is the value of friction when the block just about or just before starts to move or the surface will achieve maximum static friction mu Sn. Okay. So let me tell you one example like this. Okay, so let me tell you about this static friction first. Okay, what is actually static friction? Okay, like you see, let's say now we have a rough surface. Okay, actually I have a simulation to show you. After this video, I have a small simulation to show you exactly the difference between static friction and kinetic friction. You should look into that animation to understand more, yeah, about this difference, yeah, and also this graph. Okay, so let me tell you one example. Let's say I have a block, 10 kilogram block. Okay, on a rough surface, provided this surface is a rough surface, so it also gives you the coefficient of friction. We have a static coefficient of friction mu s, which is 0.2. We also have kinetic coefficient of kinetic friction 0.1. So this is the rough surface with all this value of mu. So we know that this surface definitely provide friction for this crate. Okay, so this crate, okay, first of all, I want to write down first the weight and the normal force, because we know that friction depends on the normal force. The bigger the crate, the heavier the normal force, the higher the friction the crate will experience, isn't it? Okay, so look at this one. So we need to first identify. So we only have this value. We have the mass. This is actually the mass, 10 kilogram. The crate is 10 kilogram, and the rough surface has this value of coefficient of friction, yeah, mu s and mu k. All right. Normally mu s is bigger than mu k. You should know that. Yeah. Okay. Now, look at this. This one. Okay. Let's find out the weight. Let's find out the weight. The weight of this is W equal to mg. So which is 10 mass. Gravity is 9.81. So it is So this is 98.1 Newton, isn't it? The weight. So we know that for this case, the normal force is actually equal to the weight, which is also 98.1 Newton. Okay. So now, now I want to ask you. Let me tell you. Yeah. Okay. Now let's say I push. Now my hand comes in. I want to push this object. I'm pushing this object. Yeah. My hand. This is my hand. Okay, this is my hand. All right, this is my hand. Now I push it. Okay, I push it. Definitely, if I want to draw the pushing force, I push it with how many Newton? Okay, I push it with. I push. This is my pushing force, my external force. Okay, my external force is, let's say I push with 1 Newton. 1 Newton, do you think the object will move? Okay, do you think? No, the object will not move yet. Okay, the object will not move yet. Okay, so yeah, if I push with 1 Newton, so this one will experience the friction will be also we experience static friction of 1 Newton also. So this is what it means by the static region here, when the object is not moving yet. Understand? The object is not sliding yet. Not sliding yet. I push with 1 Newton. So it's over here. This is my external force. You see that? This is my external force. Okay, my external force. So I push with 1 Newton. So the friction will also be 1 Newton. Yeah, I push with 1 Newton, so the friction also 1 Newton. Now I push with a greater force. I push with let's say now I push with 2 Newton. I push with 2 Newton. Okay, so the static friction will also be 2 Newton. So that means if I push with 2 Newton, the static friction also will be 2 Newton. Yeah, if I push with now if I push with, let's say I push with 3 Newton, the static friction also will be 3 Newton. Understand? That's why it's not moving. Why? That's why the crate is not sliding yet, because the static friction is, you see this one? You see this one? The static friction is equal to the external force. Is equal to the external force. Why? Why it's not sliding yet? Because the static friction is exactly equal to the static friction. The static friction is maybe I should write. The static friction is exactly equal to the external force. So they cancel each other. So the force in the horizontal component is 0. So that's why the crate is not sliding yet. So until what point I should push? Until what point? Then only will the crate will start to move. Let's say I push with, let's say I jump. Let's say now I push with 10 Newton. What do you think the static friction? Also 10 Newton. Yeah, push with 10 Newton. The static friction also will be 10 Newton. So that's why the static friction. This static friction is this static friction is not a constant value. this static friction has a various value. This static friction is equal to the external force. It is the higher the external force, the higher the static friction to grip the object in place so that the object is not moving yet. But it has a maximum value. This static friction cannot hold the crate back for indefinite time. This static friction cannot hold the object forever. If you still keep on increasing the external force, one day it will achieve a maximum static friction. If you keep on increasing the static pushing force, you keep on increasing the pushing force, this static friction also go to the opposite direction will also increase, according to the external force, because static friction equal to the external force. You increase the external force, the static friction will also increase automatically. But this static friction cannot increase forever. It has a maximum value. What is that maximum value? To investigate the maximum value, so what the surface, we can say what the surface can withstand, can hold or can grip the object before the object start moving. So that is what we call the maximum static friction. So how to calculate this maximum static friction? The formula is mu Sn. To find out what is the maximum value, we see that here. This is the maximum value before the crate start moving. So it has a maximum value. Yeah, it has a maximum value. This graph cannot increase forever. You understand? It cannot increase forever. It has a maximum value. So what is this maximum value? It is equal to mu Sn. So it depends on the value of mu. It depends on this value of mu. See that? This value of mu. It also depends on the normal force. So by using these two values, mu S and the normal force, we can calculate the maximum static friction before it starts moving. The mu S and the normal force. We can calculate the maximum static friction before the crate start moving. So let's calculate out. Yeah, we have mu S 0.2. Let's calculate. This is 0.2. The normal force is 98.1. 98.1. So 0.2 times 98.1, which is equal to 19.62 Newton. This is the maximum static friction it can tolerate. It can tolerate up to 19.62. So if your external force, let's say if your external force now be over the maximum static friction, then the object will start to slide. Will start sliding. Let's say your maximum static friction is only 19.62. Now your external force, like you see here, we know that the maximum this surface can stand is only 19.62. But now your external force, let's say your external force you push to the right, external force you push with, let's say you push with 20 Newton, just slightly higher, or 19.63. Let's say 19.63, or let's say just 20 Newton. You push with 20 Newton, slightly bigger than the maximum static friction. What will happen to the crate? It will this surface cannot hold the crate anymore. This crate will start to slide. Because the external force already bigger, already over than the maximum static friction. 20 Newton cannot. The surface can provide up to the surface can provide up to maximum static friction mu Sn, which is 19.62 only. It cannot provide friction more than that. It cannot provide 19.63. It cannot provide 19.63. Cannot. So the surface is not rough enough. The mu is not high enough to stand higher external force. Understand? So it cannot give higher friction anymore. So this surface cannot grip the block anymore. This block will start to slide. So if you push with 20 Newton or you push with 19.63 Newton, the block will surely start to slide because the surface can only provide up to 19.62 Newton based on the mu s of the surface and also based on the weight of the block. The weight of the block, 10 kilogram. Based on the normal force and based on the mu, the maximum static friction can only provide up to 19.62 only. If you push more than that, the block will start to slide. Understand? So this value mu s, the mu Sn, which is maximum static friction, is 19.62. We calculate 19.62 Newton. 19.62. So if you push up to, let's say your value push up to 19.62, that is the maximum. If you push up to 19.63, it start to slide already, become the kinetic friction. Yeah, 19.63, it start to slide. The friction will drop suddenly to another value. Because when the block start to slide, the block does not experience static friction anymore. It experiences kinetic friction. Which is mu Kn. So let me draw the block one time. Okay, now let's say now I push, because we know that the maximum static friction is 19.62 Newton. Okay, now let's say I push up to 19.63, more than the maximum static friction. So we know that definitely it start to slide already. Yeah, when it push with 19.63 Newton, more than the maximum static friction, it start to slide. So when it start to slide, that means it got velocity already. The block is already start moving. Okay, 19.63. So this is the one, 19.63. Okay, so the friction suddenly dropped to a lower value. Friction start to drop to a lower value, which is called the kinetic friction. Fk equal to mu Kn. So how to calculate this constant value? How to calculate this mu Kn? Yeah. So with that one, we use mu k already. We use this value mu k. So let's calculate. When object moving, surface only provide Fk, which is equal to mu Kn. So let's calculate the mu Kn. Mu k is 0.1. Now the normal force just now also depend on normal force. Normal force is 98.1. So 98.1. So multiply, I surely get 9.81 Newton. 9.81 Newton. Understand? So now the friction drop. The friction now drop to. The friction drop to what? The friction drop to Fk, which is mu Kn. It only dropped to 9.81 already. 9.81 Newton. It dropped to 9.81 Newton. So it dropped to 9.81. So this the surface no longer provide friction of 19.62 Newton. When the object start sliding, yeah, just now that part is non-sliding yet. Okay, this part is sliding already. Then it's dropped to sliding. Okay, just want to hold on a second. Right, just want to throw off all these values. All right. Yeah. So when it starts sliding already, the friction now becomes 9.81. 9.81 Newton. It dropped to 9.81 Newton. So it is this kinetic friction. This is actually Fk. This Fk is actually lower than Fs maximum. Lower 9.81 is actually lower than Fs maximum. Fk is lower than Fs maximum, which is 19.62. Why? Because the mu k is smaller than mu s. So the friction dropped to a lower value. When the object start moving. So the friction will drop to a lower value, even less grip. Okay. So if you increase some more, let's say you increase some more. Okay, you increase some more this value. Maybe you put in 20 Newton. Let's say I increase to 20. What is the friction? What is the friction now? The friction do not follow the pattern anymore. It do not follow the pattern. The friction is become a constant value. This value become a constant value. Last time when non-sliding, the friction equal to the external force. The external force increase, friction also increase. External force increase, friction also increase. But this time, the external force increase, the friction is constant. You see that the friction is constant at it is constant at 9.81. You increase it. Let's say 20. You don't put 20. You put let's say 25. The friction still constant. You put 30. The friction still constant at 9.81. That is for when objects start moving. The friction is always constant. Do you get that? So for this case, I have a simulation after this video to show you. You should look at the animation and try to understand the value. So in short, what I want to say is static friction has a various value. Kinetic friction has a constant value. For when non-sliding, what I can say is the friction is always equal to the external force. And the value has a maximum. This various value, but it has a limit. Just about. So whenever you see in the exam, you often see this keyword. Often see this keyword. Just about or just before the block start to slide. That means what it means is it achieved the maximum static friction. Just before the block, just before this point. What is mean by this point? This is the point. This is the point where the block just about to slide, to move. You see not? Just about, or you can say just before. This is the keyword, just about or just before. This is the point where achieve the maximum static friction. This block just about at this point is just about to change from non-sliding to sliding. You understand or not? This is the point where the block just about to change from non-sliding to sliding. This is the point where achieve the maximum static friction, and this value depend on mu s and also the normal force on the block, and also depend on the weight. Okay, so just about or just before it move, achieve the maximum static friction, which is this point. Okay, so after that point, after that maximum point, the friction will drop to a constant value, and which is also a lower value compared to the maximum static friction. It's a constant value. No matter how much you increase the external force, you increase with 50 Newton. The external force. You increase with 50 Newton, you increase with 100 Newton, increase to 150, 120, 200 Newton. This one is always constant. Unlike last time. It's always constant. Okay, so here I have in short I can say that mu s is always bigger. Mu s is, like see this example, mu s always bigger than mu k. 0.2 bigger than 0.1. This is one example only. Mu s is always bigger than mu k. So the maximum static friction is always bigger than mu k. What I'm talking is only the maximum value. I'm not talking about the static friction before that. I'm not talking about the static friction before the maximum. This one definitely lower than the kinetic friction. Yeah, what I'm talking is just the maximum value. The maximum point here, this is the maximum point static friction is always bigger than the kinetic friction after sliding. Okay, so that's all for the friction. All right, it always yeah, static friction is we consider the object is stuck. Yeah, because the surface is rough, holding back the object from sliding. Holding back, yeah, the friction. Like see this, we see this object, this block is tend to like sliding downwards, right? Tend to slide downwards, but this friction is holding back. So this object is like stuck over there. Friction, yeah. Or moving sliding object. This, you see, this friction always oppose motion. This friction always opposite the velocity. Opposite the velocity. Okay, so that's all for the friction. And then one more thing is about this external force. Yeah, external force. Okay. All right. This one I will talk in the next video.